Yeah, our session is about data structures in C. Actually, I have heard that many students feeling that data structures is very tough subject or it is very tough to understand. So I here decide to discuss about the data structures. And let's go with simple topics. And I don't lag this video. I will complete it within 10 to 15 minutes because I have observed that students they don't see the video if it is more than 30 minutes or it is 30 minutes too, they will skip it. So I will try to make it in between 10 to 15 minutes so that you can get the concept very clearly. Okay, let's go to today's topic. Yeah, here is this. These are the today's topics. First one is what is data structures. Second thing is basic things to know before going to data structures. And the third thing is algorithm, performance analysis, space complexity, time complexity. These are the things we are going to learn in this session. Yeah, let's see here. What is a data structure? Once read this definition. Data structure is in C or used to store data in an organized and efficient manner. The C programming language has many data structures like an array, stack, queue, linked list, tree, etc. A programmer selects an appropriate data structure and uses it according to their convenience. I think you will be learnt about the array in your before classes. Array is nothing but grouping of data or collection of data which are of same data type. And stack, queue, linked list, these you will learn in your later classes of data structures. Simply we can say that data structures is used to store data in an organized or efficient manner so that we can use it whenever we want easily and efficiently. Okay, let's go to the basic things you have to learn before studying data structures. See here, the first thing is the algorithm. I think you will be studied this in your before classes. It is nothing but step-by-step procedure to solve a program or a problem. If we know the code or if we know the logic, it is very easy to write the algorithm in steps. English language. Let us see an example. See this. We can also say that algorithm is a sequence of statements. Yeah, see this example. Write an algorithm to add two numbers entered by the user. See, this algorithm was in 6 steps, but we can also write this for 10 steps, for 9 steps, but the final minimized algorithm for adding of two numbers is only 6 steps. We cannot decrease it. We will use algorithm to solve the problem more efficiently, to use right tool to solve the problem, or right resources, and also to run the program more efficiently. And for a single program there will be many algorithms. Some see same for only an addition of two programs, addition of two numbers, there may be algorithm of 10 steps. Same way here we see algorithm of 6 steps. So it is up to you to decide the algorithm how many steps, and the algorithm should contain every aspect of the program, every aspect that is required for the program. So to decide this algorithm we have some basic things. So in that first one is performance analysis. See, performance analysis, it is a process of making evaluative judgment about algorithms. It means the name itself saying that analysis, it means we will analyze which algorithm, means we will select the algorithm, we will give the judgment like this. See, it is a process of making evaluative judgment about an algorithms. It means predicting resources that are required for an algorithm. Okay, see here, things include performance analysis. First one, whether the algorithm is providing the exact solution for the given problem. means whatever the algorithm you have written, that should provide exact logic and every resources to the given problem. The second one is it is easy to understand. Easy to understand, and the algorithm should be very easy to understand. It should not be very complicated, so that whenever you see the algorithm, you should be able to write the program easily. Next thing, third thing is whether it is easy to implement. Yeah, you should not write the algorithm very large. The code should be very less, so that you can easily type and you can compile it. And fourth thing is how much space it requires to solve the given problem. It means every algorithm will occupy some space in the computer memory. Here space is nothing but computer memory, that is RAM. So the algorithm should occupy less space. And the last thing is how much time it takes to solve the problem. Let's go to next topics. See, this is about performance analysis. There are problems and algorithms to solve them. Problems and problem instances. Example, sorting data in ascending order. See, we know that there are 4 different types of sortings. Among them we should select which is easy and which takes less time and which is easier to implement. So according to these categories we will select the sorting type. So here, see which is the best algorithm for the problem. How do we judge? Based on the performance analysis, we will judge the algorithm. Next topic is space complexity in data structures. See here, space complexity. When we design an algorithm to solve a problem, it needs some memory to complete its execution. Yeah, as I said before, whatever the algorithm contains, that occupies some space in the computer memory. See, these things requires memory in computer. First thing is to store program instructions. Whatever the statements we will write in the main function or wherever in the block, that requires some space. And also to store constant values, to store variable values. We know that variable values will store the data according to their data types. According to their data types, the space will be allocated in the memory. And the last thing is to store some other things such as functions, conditions, and also for function calls, etc. These will occupy space in the computer memory. See here the main definition of the space complexity: total amount of memory required by an algorithm to complete its execution. It means the algorithm should be very small and it should occupy less space in the memory, and the space is called space complexity. The total amount of memory required by an algorithm to complete its execution is called space complexity. Always the algorithm should be very small. We should maintain the space complexity. And the next one is time complexity. Let's see time complexity. It is similar to space complexity, but here total amount of time taken by an algorithm to complete its execution means time complexity, whereas we have studied that space complexity means total amount of space occupied by the algorithm for its execution. See, whether it is running on single processor or multiprocessor, every algorithm's running time depends on the following things. They are whether it is running on single processor or multiprocessor. We already know that the single processor cannot do multiple tasks at a time. The multiple processor can perform multiple tasks at a time. So we can say that the algorithm running time depends on this. And also second thing is 32-bit machine or 62-bit machine. We know the 32-bit machine can compile only 32 bits at a time. So this is also takes a part in running time of the algorithm. And last thing is read and write speed of a machine. We know that if you want to travel from one place to another, we will choose a shortest path. Same like that here also, based on this time complexity, space complexity and the performance analysis, we will choose the algorithm which occupies less space and takes less time for its compilation and for its execution. So for these things we will use this time complexity and space complexity as well as performance analysis. And the next topic is asymptotic notations. They are of 3 types. We will discuss that in next video. And thanks for watching this. And if you have any doubts, please type in the comment section. I will definitely reply and I will clear your doubts.